So let's write some unit tests and get our matrix class implemented. One other thing I needed to mention, or I wanted to mention, is I'm being very picky about putting this declaration up here. But if you think about it, this matrix2d.inl file, if we bring that up, it puts the declaration and the definition in there. So remember, the preprocessor will literally copy this and paste it where this INL file is. And if you look at that visually, what we have is we have a declaration here, but then we pretty soon thereafter meet the definition. And so if we wanted to, since most files that include this Matrix2D header file, they will be using this operator below where they pound include it. I guess technically I don't necessarily need a declaration. I could probably get away with it because this serves as the declaration in the header file combined with the definition to be inlined. But I tend to like my header files to have all this declaration or meta info, if you would. It says what it can do, and then if you want to see how it's done, it's over here. But at least here in the header file, you can see everything that it can do. Also, another reason to keep it in, if I bring all that back, is say up in here I needed, not necessarily in the constructor, but somewhere in some operator of matrix or something, I needed to use the multiplication operator before it's actually defined. I would either have to move this definition elsewhere higher above where I use the multiplication operator, thus, or I can just have the declaration and let the linker patch it up later. Alright, that's another benefit for having all these declarations in the header file as well, as somewhere if I had other functions here for whatever reason, and I'm just kind of making something up, but if I had functions here that were inlineable, then I could use that operator, my matrix times a vector. And the compiler can see, hey, alright, well, we know we'll bump into it later, and it does right down here, but in the meantime the compiler won't flag an error, and the linker will be responsible for patching that up. Anyway, so I just want to point that out. Let's stub out some, or let's write some unit tests. Let's write unit tests for our constructor here. Let's write unit tests for our operator multiplication. So I'm going to say engine tester, set you a startup project, go to Matrix2D tests, and nice thing about that Google test, now that we have it installed, is we're going to do, the category is going to be Matrix2D, and let's test construction. And then here we're going to test Matrix2D, same category, and we're going to test matrix vector multiply, and stub that out right there. Okay. So construction should be pretty straightforward. Matrix2D. Oh yeah, we need the namespace. Using math Matrix2D. Then here matrix 2D. I don't know, subject. Subject. Let's start with the identity matrix, and we'll call it identity. And then expect float equal expect. Oh, I forgot to pound include Google test. No wonder I'm not even paying attention to all the red squigglies. I think I'm just used to having IntelliSense having personal problems, so I've totally ignored them. Pound include gtest slash gtest.h, and we'll keep that there. I'm going to pound include that. Since that's somewhat standard, somewhat middleware, I'm going to include it higher than my own header files. Expect float equal identity dot whatever, comma, and I'll put a 0 there, and then control L v, and then this should be 1 0 0 1, and this is going to be row 0 column 0, row 0 column 1, row 1 column 0, and this is going to be row oh, did I put an F there? Sheesh, you're probably watching my videos thinking, "Golly, Jamie, you're not a very good programmer." That's a row 1 column 1. Okay, so that's kind of embarrassing. Rough day, a lot of videos today. And okay, what's it crying about? So float, and then this should be like that. Like that, like that, and like that. Okay, what's the F1? That's right, I changed it. R1. Okay, so I'm going to build this run. This should get a lot of red because we didn't implement the constructor. And yep, failed. All right, Matrix2D construction failed. Good. Let's go implement it now. Matrix2D INL. And this should be pretty straightforward. Now I'm going to use an initialization instead of assignment. I want to initialize these values. So let's just cheat here. I'm going to Control-C, Control-V, do a little magic, Control-Shift-R, record a macro, Control-Delete, Control-Shift-Right arrow, Control-C to copy, open parenthesis, paste, open parenthesis, over, stop. Watch this. Boom! That's so hot. Go down here, Control-Shift-P, Control-Shift-P. And I still have the Fs. Oh boy. There we go. So now, and I need the initializer list as well. Again, if you need to see the C++ list on initialization versus assignment, we want to initialize here because generally constructor is good for assigning small values. I generally use an initialize function to do anything larger. But then I could do the assignment, and I don't think it would really make a difference. I could come down here and say R0, C0 gets R0, C0. But now, since I have a ambiguity between what's what, I have to put the this on here, like so, to disambiguate. But then also, with primitive types, it doesn't really matter. I mean, the initialization pretty much does the same thing as I just deleted down here. But with larger initialization, especially with larger types or more complex types, initialization is very critical. It can save you a lot of time and headache and reduce the amount of memory allocations you do if done right. Yada, yada, yada. Go watch the video on... let me go find it. So I found it here. It's C++ initializing larger data members. If you look at the C++ playlist and you look at maybe the video or two before this, and then especially this video, I point out why it's good to do initialization. Okay, so we just did all that. Control F5, build. Boom, we got green, feeling good. Time to check in. Hold on, I'll pause the video while I do. Okay, so now let's implement this operator. Vector times the... Oh, wait, let's not implement it. Let's test it first of all. Matrix 2D. Let's just do... I'm going to call it operator. Ooh, that goes blue because that's a keyword. Let's call it op. Generally, or often, people say this is the matrix operator. When I take a matrix, notice I'm writing this kind of in capitals, and I times it by a vector, or I multiply a vector by this matrix. This is kind of considered the operator, even though the multiplication is really the operator. When you think of the matrix as the operator, because it is what's doing the transform on the vector, meaning it's going to change the vector somehow. So anyway, all right, let me clear that off. I'm going to call that operator, or op, and let's give it values. Oh, simple stuff. 2, -3, and then just for syntactic help there, 4, -5. And then vector 2D. I forgot the using for it. Using math vector 2D. Vector 2D victim. And let's just do 3, 9. I'm just making up numbers as we go along here. Maybe some white space would help. You see, I kind of laid this out as a matrix. That's why I syntactically brought this down to the next line. I could as easily just had this on the same line like this, but I kind of think it helps to see the syntax like so. Okay, so vector 2D victim victim prime gets the op times the victim. So I'm going to multiply the matrix times the victim. Now why did I call this victim prime? Well, that's just a mathematical term. We say vector v, and if I take a matrix and I multiply that matrix times this vector, or I use this transformation against this vector, then that's going to give me v prime, which is a fancy way of saying the result. Like we're moving from here and we're going to here. And so you can think of it as the result. That's kind of a fancy way of what they're saying there. Okay, so expect float equal victim prime dot, and I'm just doing the same thing here. I'm saying let's do 0, 0, f. I'm doing the same thing as I did here before. I'm just trying to get a line I can copy and paste real quick. And actually, it's just the we need victim prime. It's a vector 2D, so we only need to test 2 values. So what are the values going to be? Well, let me jump into Khan Academy mode or something and try to describe what's going on here. We have this matrix here, 2, 4, -3, 5. And we have this vector. I better do this as a matrix. And this looks, I'm going to draw this like a matrix, it's, even though you can think of it like a vector. This vector 3 and 9. And so, yeah, I can take this row and times it by this column and then get a value out for sure. Or I can think of this more like linear algebra, where we're saying 3 times this vector plus 9 times this vector. Let me highlight the vectors in here. 3 times this vector plus 9 times that vector. So 3 times 2, 4, plus 9 times -3, 5 equals what? Well, 3 times 2 is 6, 3 times 4 is 12, plus -3, did I have a -3? Yeah, I had -3, so -27. And 45, man, I remember that from 3rd grade. That's amazing. Okay, so what's -27 plus 6? That's going to be a -21. And 12 plus 45 is 57. Okay, so expect float equals victim prime dot x should be -21.0. And victim y will be 57.0f. Okay, let's build it, run it. Hopefully it crashes red. If it passes first time, I'm not going to feel good about that. Ah, it failed. Good job. Ah, okay. So let's implement this. Let's go over to Matrix2D.inl. And I see this video we're hitting upwards 13 minutes. Again, don't feel obligated to go through the unit test. If you want to skip it, feel free right ahead. It's could be your loss or it could be your gain, one of the two. Okay, let's start. I'm going to start coding this simply, and then we'll do some tricks to optimize it a little bit. I'm going to say vector 2D. I'm going to make it temporary. Vector 2D temp, and temp dot x gets, I can literally, now that I have this onto the right side, I can literally just type in the code to make this happen. So it's going to be left. Okay, left is our matrix operator. It's left dot row 0 column 0 times right dot x plus left dot row 0 column 1 times right dot y. Is that right? So, whoops. Left r0 column 1, row 0 column 1 is this, and right dot y is 9, so that'd be -3 times 9. Good. And that will give us a result of -21. Actually, this left and right's throwing me off. Let's do a better naming convention. Let's do, could we call it operator? No. Let's just call it op for now, and right will be vector. How about that? I think, well, we'll see. Well, I'm going to go with this. The left and right, when I'm multiplying 2 types that are identical, left and right has a lot of meaning to me, but now that I have these, like a matrix and a vector, I want to keep things straight. I guess I could call this matrix and vector. Yeah, good. Let's go over here to Matrix2D and just change that as well. Matrix and vector, save, close the file. Alright, temp dot y gets left dot row 1 column 0 times right dot x plus left dot row 1 column 1 times right dot y. Okay, so let's just visually inspect that. It's going to be left row 1 column 1, so this 4 times right dot x is 3, so that's correct, plus left row 1 column 1 times right dot y, so 9 times 5. And add that, that should give us 57 in this case. And then we can return temp. Return temp. Now, if you've done any matrices before programming, you might be thinking, Jamie, why don't you, instead of calling this row 0, column 0, why don't you make an array and then do a for loop, and that's just so much for fancier. And I'll tell you why I don't. 1, readability. 2, there's a good chance, but not always true, the compiler could look at our loop and realize, you know, you don't really need this loop. I can just unroll all this code for you, and literally just do semantically. Semantically, you'll get the same thing, but underneath the hood, I'll just unroll it and hard code all these values for you. And the compilers may or may not be that smart. Either way, I'm kind of beating it to the punch. 1, I like the readability of this. I know that multiplying a 2D matrix times a vector 2 is not going to change, at least hopefully not in my lifetime. And also, I don't have to write the loop, and I don't. Every time I want to multiply a vector times a matrix, I don't have to eat the cost of having a for loop and an iteration variable, and also doing the offsetting into the matrices. So I think this is good. Let's see if this builds. Build start. Of course, it doesn't build. Left of y must have a struct. What is the? Oh, did we do it again? Did we do it again? What did I do? What did I do here? Let's get Matrix2D, and let me pause the video, figure out what's wrong. An amazing thing happens when you stop looking at your code for a minute and come back, and I got left and right here, and I should have called this matrix. So everywhere I see left, I need matrix. You probably were watching that thinking, Jamie, you didn't rename your variables. Hello? Yeah, that's fine. If you you can be this awesome programmer and then miss all these little things. And I also notice I have inline here again. I don't need inline. If we have Matrix2D, we already declared it as inline. There's no need to repeat that. I know in C#, I do a lot of C# programming too, and when you rename a variable, you can just hit Control dot and it'll go through and rename all the variable references for you. I don't know why I let that slip, but C++ and Visual Studio does not have that feature. Let's see if this builds. Even though we have the red squigglies, build succeeded, good. And now our test should pass, if I remember right. Let's just go double look at our Matrix2D test. I should put these in subfolders, but yeah, okay, let's run this. Build, run. Oh! Failed. Wow. Of course it failed. I probably made an error in the math, and you're probably laughing at me thinking, Jamie, you're making so many errors this video. You've been programming way too long, doing too many videos. I put a breakpoint here, hit F5, victim prime. Let's just see what we got here. We said that the result should be negative 2157, so I got negative 21. Now what's y? It's negative 33. Why is that? Either my code here is wrong or my test is wrong, but at least one of them's wrong, and I'm double checking myself, and hence the benefit of using unit testing. I mean, yeah, this is painful. It's a long process, and the videos are getting quite long too with the unit tests, but now I'm double checking myself. So row 1, column 0 times 3. 3 times 4 is 12. That's right. Plus row 1, column 1, 5 times vector y, 9. 9 times 5 is 45 last time I checked. So why am I getting 57, 45? Yeah, but this is coming out as a negative 33. So row 1, column 1 is 4. That's correct. Vector x is 3. That's correct. So 3 times 4 is 12. And then row 1, column 1, that's negative 5. Why negative 5? Why is that negative 5? Did I say negative 5 and I missed it? Oh. Oh. Hopefully you're skipping the unit testing videos. I'm going to keep this video. I'm making a lot of mistakes. I think it just proves to you. It shows a good debugging tool. Shows that I'm not perfect for sure. Unit testing is error prone, but still, you're writing extra code to test your code, so why not? So anyway, let's see. Before I just go type what the result here is, let me shift F5, get out of that. I'm going to F5 again, and F11, step in, And we said this is going to be negative 33. So 45, this is going to change to a negative 45. So negative 45 plus 12 will be negative 33. So yeah, I made an error while I was doing my unit tests, but at least I caught it, and I can feel even better now that I've caught that error. Let me show you one other debugging trick I was tempted to do, but I didn't end up doing it. But I think it'd be good to show. Is notice I'm saying row 1 times vector x. That should be a 3. So 4 times 3 is 12, all right? But now I have to think 4 times 3 is 12, and then now I come over here. Negative 5 times 9 is negative 45. Well, if I don't want to keep those things straight in my head, I can bring up the watch window here. I can grab this expression, drag and drop it in. And then I can grab this expression, drag and drop it in. So now I can see 12 pairs up not quite nicely with our 12 here, and our negative 45 pairs up quite nicely with this negative 45. So just another debugging trick. You can type expressions in here and evaluate them. So let's Control F5. I'm still seeing red. Still seeing red. Okay, and that's because we didn't change this to a negative 33. Control F5. Whew, green, feeling good. I better check in before I change anything. Alright, video over. Check in. Let's use this matrix to do something interesting.